Hey guys, it's Ian. That's the eraser. Great start. And this is gonna be like types and then like the modeling of adding addition and subtraction word problems. So this is actually gonna be like two homeworks in one. I don't know why this one says unit one. We did it in unit two, but ignore that. And yeah, so it's just gonna be two sheets in one. So first one, we're gonna start off with the easier one. This one was a graded assignment, so most of you should have done it. But just a quick review of like the like types of problems as well, and also just like easy before we get to the multi-step, which is what we're going to need for the final, the multi-step problems. So just looking at these, we have Sam has some marbles in his pocket and found 81 more marbles and had a total of 217 marbles. So how many marbles did he have at the start? Um, the way you solve it is going to be different than like the actual type of the problem. So just looking at like how like the type like how like what is happening in the problem. That's what I was looking for. What is happening in the problem? So Sam has marbles and he finds 81 more, and then now he has a total of 217. So he has marbles and he found more, so he's adding to his total. So that is going to be your type of problem for this one. Add to. Next, we got to draw our strip diagram to show what's happening in the problem. So then for this one, I would just draw a little rectangle like this. Right? He has marbles. We don't know how many. He finds 81 more. He has a total of 217. And that's it for your strip diagram. You just got to show what's happening. And the question mark needs to be what you're finding. So we have the number we know, total, and then the number that we're finding. Then solve it. So since we have our total and we have one number and we need to find the other number, we're going to subtract. And you can use any process you want. You just have to make it shown. So I'm going to use standard algorithm for all of them, probably. 7 minus 1 is 6, and then borrow 11 minus 8 is 3, and then the 1. And then you have to remember your sentence. And the sentence needs to show that you know what's happening in the problem. So Sam had 136 marbles at the start. Yeah, this first sheet's going to be a breeze. Second problem. 24 pencils in a bin. 13 of them are red, and the rest are green. How many pencils are green? So, what's happening? You have your total. You have 24. You have 13 red. The rest are green. All of them are already present, though. You're not adding any more to the mix. You're not taking any away from the mix. They're all there. Two separate colors. I believe you're putting them together. So, that's going to be our put together slash take apart. So then we have to draw our strip diagram to show what's happening. We have 24. 13 are red. The rest are green. We're finding the green. That's what the question mark is saying. We're finding green. From here, just solve it. So we can do 24 minus 13 is 11. And then do our sentence. There are 11 green pencils in the bin. And look at that. sentence matches the context of the problem, and we can move on. Julia has had $5 more than Stephanie. If Julia has $18, how much money did Stephanie have? Okay. Seems like Julia has money, and she has more money than Stephanie. I feel like we're comparing the amounts of Julia and Stephanie. Hello. The eraser keeps popping up. I didn't even underline it. Oh. There we go. Compare. Now we need our strip diagram. Compare. Can't really do what we've been doing. So we're going to have Julia, and we're going to have Stephanie. Now Julia has $5 more than Stephanie. So Julia's box is going to be larger than Stephanie's because she has more money. And then Julia has 18. So we need to know Stephanie's. And we also know that this section is 5. And look at that. That's all we need. Question mark in the spot saying that we need to find Stephanie's total. Then we can solve. 18 minus 5 is 13. Stephanie had $13. Finally, Matthew had money in his coat pocket. Some of the money fell out, $17 to be exact, and he was left with $25. How much money did he originally have in his pocket? So, he has money. Some money fell out. He lost it. It's gone. We are taking away that money. And that's our type of problem. Then, strip diagram. So we don't know the total. We don't know what he had. And we know that he has 25, and he also lost 17. So the money that he lost and the money that he has now is going to equal his total. And we need to find that total. So then what we can do is to solve it, 25 plus 17. And then 2 plus 1 is 4. So Matthew originally had $42 in his pocket. Look at that. Just a quick glance at this first sheet. These are the types of problems, the strip diagrams, the way to solve it, and the sentences. So that's just a quick little refresher with one-step problems. Now we're going to move on to the next sheet, which does a little bit more. Should be this one. Yep. All right, we're going to start off with Caleb brought fruit to a picnic. He brought 25 slices of watermelon, 36 slices of cantaloupe, and some honeydew melon. He brought a total of 100 slices. How many slices of honeydew melon did he bring? Now, sounds like, because we're listing 3 different types of fruit, it does sound like it's a compare problem. But we're not comparing, like, he brought more watermelon than he brought more cantaloupe than watermelon. Like, we're not doing that. He brought the 25 watermelon. He brought the 26 cantaloupe. He brought some honeydew. And we know the total. So in this problem, we're essentially like putting together all of the different types of fruit to get the total number of slices. And that's we're putting together to get the total number of slices, and we're taking apart to get the slices of honeydew. So that's actually the put together, take apart. That's our two types of problems in one. So we need to draw our strip diagram. So we know the total is 100. We know there's 25 watermelon, 36 cantaloupe, and some honeydew. And we need to find the honeydew. So how do we solve this? First, 36 plus 25. 6 plus 5 is 11. 3 plus 2 is 5 plus 1 is 6. So we have 61. Without honeydew, he brought 61 slices. From here, we have 100 minus 61. Or with the power of compensation, we have 99 minus 60, which is 39. And that's our final answer. So we add up what we know, right? We add up the total slices of watermelon and cantaloupe, gets us our current total without honeydew. Then we take the actual total minus the watermelon and the cantaloupe to get the amount of slices of honeydew. And then we still need our sentence. Caleb brought 39 slices of honeydew. And there we go. Next up, we have Mrs. Charles drove 325 miles on Saturday. She drove 49 miles less on Saturday than she did on Sunday. How far did she drive on both days together? So, looking at it, right, reading the problem, she drove X amount of miles on Saturday. She drove less on Saturday than she did on Sunday. So we're comparing Saturday, Sunday. And then the question wants to know how far did she drive on both days together. So we're comparing Saturday and Sunday, and we're also putting Saturday, Sunday together to find the total number of miles on both days. So our types of problems are compare and put together, take apart. So now we have our strip. We need to draw our strip diagram. So we have Saturday and we have Sunday. So we know Saturday, she drew 325 miles. Drove, not drew. Whoa, hello. She drove 325 miles on Saturday. She drew less on Saturday than she did on Sunday, which means our Sunday box is going to be larger than Saturday. Like that. It's a funky looking box. Oh my god. And then since Sunday's larger, we know that this empty space this is 49. I don't like the way that looks. Hold on. Yep. All right, 49. And then what we need to find is that total. And that's it. That's our strip diagram. So then, how do we solve this? Well, we know Saturday. So that step's already done. If we do 325 plus 49, and get 374, now we know Sunday. Oh, also, notice how I didn't put a question mark inside Sunday's box? We don't know it, but we're also not trying. Like, that's not the goal of the problem. So we don't know it, so I left it blank. But the question mark only goes on what you're trying to find in the problem. So so the question asks, how far did she drive on both days together? The question mark's on the total, not on Sunday. So 325 plus 49 is 374. So now we know Saturday, and now we know Sunday. So now we did the compare. Now we do the put together part. 374 plus 325 is 699. What was her name again? Mrs. Charles? Mrs. Charles drove 699 miles total on Saturday and Sunday. Boom. I got Flyers notification on my computer. They're tied. Oh, okay. Arthur scored 258 points at a carnival game. Joelle scored 84 more points than Arthur and 68 more points than Ruth. How many points did the three children score in all? Looking at it, we're obviously comparing. And it's like kind of like this one in the sense that like we're putting the total together at the end. So it's another compare and put together. So now we got to draw our strip diagram. We have Arthur, we have Joelle, and we have Ruth. And we know Arthur. He scored 258. And we know Joelle scored Arthur's plus 84. So these are actually the same amount. And then Ruth is more than Arthur, but less than Joelle. And we know this because Joelle only scored 68 more points than Ruth. So Joelle, like this isn't changing anywhere. This is a number. This specific number that Joelle has that we do not know yet is 84 more points, is 84 more than 258. Joelle's specific number that we do not know yet is also 68 more points than Ruth. So we can kind of draw our box like this. Oh, I lied. Kind of draw our box like this. And then this space here is 68. That's the 68 more points. That's the 68 less points that Ruth has compared to Joelle. And then we want to find their total. So then from here, we know Arthur's is 258, and we know Joelle's is 258 plus 84. We don't know what Ruth has. We don't know what its is plus 68. So we can't do anything with her yet. But knowing what we do now, we can do 258 plus 84 to get 342. So now we know Joelle has 342. In order to find Ruth, we need to take Joelle's 342 and subtract 68 from that. To get 274. So now we know Arthur's 258, Joelle scored 342, and Ruth scored 274. Now we just add them up. And we know that their total is 874 because we added Arthur's 258 plus Joelle's 342 to get 600. 600 plus Ruth's 274 to get 874. And now we can say the three children scored 874 points in all. And then finally, Ivan has 400 more stickers than Tom. Go, Ivan. Tom has 350 more stickers than Peter. Altogether, they have 1,157 stickers. How many stickers does Peter have? So, seems like we're comparing the total of Ivan's to the total of Tom's to the total of Peter's. And then it also gives us the total that they all have, which means that we're comparing their three totals and also putting their three totals together. So, yet again, this is compare and put together. So, now we can draw our step diagram. We have Ivan, we have Tom, we have Peter. So Ivan has 400 more stickers than Tom. So Ivan has a number, Tom has a number that's 400 less. And then Peter has a number that's 350 less than Tom. So if you really think about it, they're in like decreasing order. Peter is the base amount. Because Tom has more than Peter, Ivan has more than Tom, which means that Ivan has more than Peter. So Peter has the least. Peter has the base amount, the base block. I drew his block first. From here, Tom has Peter's exact amount plus another 350. And then Ivan has Tom's exact amount, which encompasses both Peter's exact amount plus this 350 plus another 400. And then in total, they have 1,157. And then the question is, how many stickers does Peter have? There we go. So, how do we solve this? In order to find Peter's amount, Peter is the same as like this unmarked box from Tom and this unmarked box from Ivan. All three of these boxes, not including these three, All three of these are the same size. They're equal. They're equal. That's the big word there. They're equal. That sounds like it could be division because we can divide into our three groups. How do we get it to there, though? In order to get into equal groups, these three boxes with numbers have got to go. So, good thing we know the total because these can, like, we can get rid of these in an easy way. 350 plus 350 is 700. Plus another 400, that's 1100 or 1100. So 1100. So then we have the 1157 minus 1100. So let's write this down. 1157 minus 1100 is 57. Wowza. Now from here, 57 is the total of all three of these boxes that, might I remind you, are the same size. Now what do we do? Well, this was mainly addition subtraction, but we got to sneak a little division in here. We got to do 57 divided by 3. Now, just to show for this, I'm going to do long. I'm going to do the tradition, like the standard algorithm for long division. So 1, 3 is 2, and then 7, 0. That's a 0. And there you go. 19. All three of these boxes equals 19. And you stop there because since all three of those boxes equals 19 and Peter's total is just that box that equals 19, Peter has 19 stickers. And there you go. That's the whole problem. And yeah, so there we go. That was types and modeling of addition and subtraction, both one-step problems and multi-step problems. The one-step problem was just like a review of like the types and how to draw the strip diagrams. What you're really going to want to know for the final, according to the sheet, is going to be the multi-step problems. And yeah, okay, happy studying.